Hi everyone, welcome back to chemistry. In the last few videos, we were talking about ionic bonding and ions, which means transferring electrons, right? Compounds that are created from the transfer of electrons. And now we're going to move into covalent bonding, which is all about sharing electrons, atoms that are sharing their electrons. And these are also called molecular compounds or molecules. So you might have heard the term molecules. We only use the term molecules for things that are covalently bonded, things that are sharing electrons. And in order to talk about how molecular compounds are created, we need to talk about how we name molecular compounds because they are pretty different, and the way that they're named can make a big difference in showing what kind of molecule you have. For instance, I've talked about it several times, but there's a big difference between carbon dioxide, and carbon monoxide. But when you look at these two words, really the only difference is this here. Maybe really just this, right? We have carbon bonded to oxygen, and this, what we call prefix, tells us what kind of molecule we have, how many of our various atoms are bonded to how many of the other atom. And carbon dioxide and monoxide are very different compounds. Okay, so just real quick, our learning goal for today is that if you are given the formula of a molecule, you need to be able to write its correct name. And if you're given the name of a molecule, you need to be able to write the formula. Okay? All right, so a little bit about covalent bonds first. So molecules or molecular compounds form when atoms of two or more nonmetals, remember covalent is nonmetal plus nonmetal, when two atoms of two or more nonmetals share electrons to form a covalent bond. And valence electrons are shared by nonmetal atoms to achieve stability. So again, remember, everyone wants to be like a noble gas, and noble gases are extremely stable. And so if we have the right number of valence electrons, either by transferring in an ionic bond or sharing in a covalent bond, we're happier. So, and then a molecule is a discrete group of atoms in a definite proportion. So that's just saying, right, CO2 means that there's one carbon for every two oxygens. And that's a different compound than CO, which means there's one carbon for every one oxygen. Right? They're a discrete group of atoms or a specific group, and it's a definite proportion that they bond in. Okay, so when we name molecular compounds, just like when we name ionic compounds, we have specific conventions that we use to name these compounds. So for molecules, remember, molecules are made of nonmetals, right? Nonmetals bonding with nonmetals. So the first nonmetal is the first nonmetal in the formula is named just by its element name. So just like carbon dioxide, we just list the first nonmetal, carbon, as just carbon. We just say carbon, okay? And then the second nonmetal is named using the first syllable of the name, followed by the ending IDE. So remember, just like we did with ionic compounds, we would say oxygen would be oxide instead of oxygen, oxide. Fluorine would be fluoride. Chlorine would be chloride. You're giving it that ending IDE, okay? But molecular compounds are really interesting because when they bond, we need to show the exact number of atoms that are bonding. So for instance, carbon oxide, if we just named it like this, wouldn't we give CO the same exact name? Yeah, but they're not the same compound, right? We just talked about that. So what we did was we came up with these prefixes that we would use to name our compounds, to tell how many of each of those individual atoms we have. If there are 2 oxygens, using this list, what would the prefix be? Yeah, it would be di. Oops. Di. 2 is di in our prefix list. So we'll go ahead and put di here. Why am I putting it in front of the oxygen? Why am I putting it in front of oxide? Yeah, because I have 2 oxygens. I don't have 2 carbons, so it's not going to go here. Right? I have 2 oxygens specifically. So the prefix goes in front of the atom that it relates to. So if you have a 2 there, you're going to put di in front of whatever atom is there. Okay, I hope that makes sense. What we also do is think about, let's do this down here. Think about carbon monoxide. So carbon monoxide is how we write that. Why do we put that mono there? Yeah, to show that we have one of our oxygens. That's the prefix. So we put that monoxide in front. Okay, it's not mono-oxide. If it's a vowel right here, we drop the vowel right here. Okay, so if there's 2 vowels in a row, we drop one of them. Okay, so instead of mono-oxide, because that just sounds kind of weird, we say monoxide. Oops, I kind of messed up my word here. Okay, why don't we put mono right here? Yeah, it's just because it would be kind of redundant. If it's the first word in the compound or the first non-metal listed, we don't have to put mono in front of it. If there's more than one, like if it was di, or if there were 2 carbons, we would have to put dicarbon in front of there. We would say di in front of there, and that just shows that there's more than one, or it tells you the specific number. If there's nothing in front of your first non-metal, that just means you have one of them. Okay, that's just the convention. That's just what we do. So you're not going to say monocarbon monoxide. It would just sound kind of weird. We just assume if it's just carbon there, then we only have one of them. If it's, 3 carbons, then it would be tricarbon. But you do need to memorize these prefixes, okay? You need to know that 1 is always mono, 2 is di, 3 is tri, 4 is tetra, penta, hexa. And some of these, you can cheat a little bit, like thinking about prefixes for other things, like octa, right? That's like an octopus, has 8 legs. Let me think, decade, like decade, deca, like decade. Is 10 years, right? Hexa, like a hexagon, has 6 sides. Pentagon has 5 sides. Triangle has 3 sides. Yeah, so hopefully that kind of makes sense. Okay, so there are several compounds that can be formed from the same 2 nonmetals, like I said. So the number of atoms present is indicated by the prefix. When the vowels appear together, the first vowel is omitted. And again, is that always true? Pentoxide, tetroxide. Oh yes, it is tetroxide. Yeah, so it is always the first vowel. Sorry, spelling's not really my forte. Okay, so naming the molecular compound, NCl3. So go ahead and try this out on your own. How are we going to name this compound? You need to have those prefixes. So if you want to have your book open and you be looking at the prefixes while you're trying to memorize them, that's okay. But try this out. Okay, so what 2 atoms do we have here? Let's just do this over here, NCl3. So what 2 atoms do we have? Well, I guess in this case 4 atoms, right? But 2 types of atoms. Yeah, we have nitrogen atoms, right? Nitrogen and chlorine atoms. How would we know that this was a molecular compound rather than an ionic compound if we weren't told? Yeah, these are both nonmetals. Yeah, nitrogen's a nonmetal. It's on the right side of the periodic table there. So is chlorine, okay? Both gases at room temperature. Okay, so they're nonmetals bonding together, and we know how many of each we have, but we need to say that when we name it. So what do we do with the first nonmetal? Yeah, we just name it nitrogen. Nitrogen, okay? And then what about our second one? Chloride, right? We know it's going to look like that, but something has to go here. And sorry, these are actually two words. Whoops. So I'll leave myself a little more space. So what goes in that box there? How many chlorines do we have? Yeah, 3. So what do I need to say? Tri. I need the prefix tri. Yeah. And this is actually not capitalized either. Okay. So naming this, we would say nitrogen trichloride. Why don't we have mono right here? Yeah, because it's the first atom, or the first nonmetal, so we don't have to put mono in front of there. If I had 2 nitrogens, what would I put there? Di. Yeah, it's just the mono that we drop for the first one, for the first nonmetal, okay? And then I'm going to capitalize this as well. So it's kind of like a name now, right? We named it. So nitrogen trichloride. All right, let's try this one too. B2O3. B2O3. All right, what's B? Boron. Yeah, what's O? Oxygen. Okay, boron and oxygen. So how many borons do we have? 2. Okay, so now we do need to put a prefix in front of that boron, right? So let's go ahead and list boron. And then oxygen becomes oxide, right? So what goes here and what goes here? And again, I didn't give myself enough room. So what prefix do we have for boron? Yeah, di. Why? Because we have 2 here. 2 on our prefix list is di. Yeah. Okay, what about oxide? Oxygen. How many oxygens do we have? 3. Yeah, so what goes here? Trioxide. Yeah, we have 3 of them. So we have to show how many we have. Likewise, when you were reading this, just by reading this, you would know, as long as it was named correctly, you would know how many of each thing you had. So you would know if you have boron, right? You have 2 of them, because there's that di prefix. And you would know you had oxygen, and you specifically had 3 of them. Okay. Yeah, so this is going the other way. So write the molecular formula for diphosphorus pentoxide. So what 2 atoms do you have here? Types of atoms. Yeah, we have phosphorus ones, and we have oxygen. So that's P, right? And O. But now you got to figure out how many. Okay, so phosphorus was listed first, so P is going to be the first one we list. O will be the second. And now we got to figure out what goes in these spots. So pause the video, try it out, see how many go in each spot. Okay, what's the number for di? Yeah, 2. Diphosphorus pentoxide. What's the number for pent? Yeah, 5. Pentagon, right? A pentagon has 5 sides. That looks like this, right? Pentoxide. Yeah. Why isn't it pentaoxide? Yeah, we drop that vowel. Drop that vowel because pentaoxide sounds like a little bit of a mouthful. Okay, so pentoxide. Yeah, P2O5. Yeah. Okay. So that's all great. When we know something is covalent, then yeah, we can name it, right? When we know something's ionic, we can name it. But you also need to know, if I don't tell you, whether something is ionic or covalent. And there's some ways that you can do that, okay? So a compound is usually ionic if the first element in the formula or the name is a metal or the polyatomic ion NH4+. So again, even though polyatomic ions have these nonmetals in them, they overall have a charge, right? They are ions. So when they bond, they're going to bond with a charge that's the opposite charge. And they're going to form an ionic compound. So that would be ionic. So that's one example of a polyatomic ion that would be ionic. Okay. It's also, another way you could think about it is if you're looking at the first atom that you see, if it's a metal like potassium, right? Potassium's in group 1A on the periodic table, that's a metal. So that compound would be ionic. Okay. Because remember, ionic is metal plus nonmetal. Okay. Likewise, for covalent compounds, a compound's usually covalent if the first element in the formula is a nonmetal. So looking here, nitrogen, that's a nonmetal. So we're going to assume, right, that it's a covalent, that it's covalently bonded because we have two nonmetals. Nonmetal plus nonmetal equals covalent. Covalent, sharing those valence electrons. Like cohabitating is sharing a house or a habitat, whatever. Okay? And then if it's covalent, we name it with the number. We have to show the number of each atom we have. Okay, so let's go ahead and pause and do this learning check. So identify each compound as ionic or covalent and then give its correct name. So there's 2 steps. Okay, so pause the video, try it out. Okay, so for the first one, SO3. Why is SO3 covalent? What kind of what was your thinking for that? Why might it be covalent? Yeah, you could have noticed that the sulfur and the oxygen were bonded together, and those are both nonmetals, so that's a covalent molecule, covalent compound. Yeah, it's also called sulfur trioxide. Remember, you don't have to say monosulfur, right? If you just list sulfur, that means you have one of them. So sulfur trioxide, we have 3 oxygens. Since it's a covalent compound, we have to show exactly how many of those atoms are bonding together. So we have to say sulfur trioxide. Okay, what about for ionic, for this next one, BaCl2? That one's ionic. Why? Because that Ba, barium, is a metal. You've got a metal with a nonmetal, chlorine, so we're going to assume that's ionic. And how do we name ionic compounds? Thinking back to a previous video, we just say the first, the metal is always just the name of the metal, so barium, we don't change anything. And then chlorine is now chloride, right? It's got that ending IDE. All right, the next one. This one's a little bit harder because you might have been confused about this polyatomic, right? This is ammonium. So we leave that as ammonium phos. Oh, and this is also a polyatomic as well. Yeah, so you would have to know both things. You'd have to see that it was ionic, right? So when this NH4 here has a +1 charge, and the PO3 has what? 3 minus. Sorry, I should say 1 plus. And 3 minus. Okay? And that makes sense because we have 3 of our positive charges bonding with 3 of our negative charges. Okay. Anyways, so those are both ions and they're bonding. So that's ionic, right? And we then just say the names of the polyatomic ions. So we have ammonium and we have phosphite. So when they're like polyatomic ions, we just name them what their actual names are. Okay, so ammonium phosphite. Why isn't it phosphate? Yeah, because if it doesn't have the 4 here, PO4 3 minus is phosphate. Okay. Next one, copper And what's that next one there? Yeah, that's carbonate. How do we know it was carbonate? We memorized it. Yeah, we memorized it. It's one of our polyatomic ions that we had to memorize. What's the charge on carbonate? Yeah, CO2 3 minus. Sorry, CO3 2 minus. Yeah. This one was also a little bit tricky. Okay, so let's actually do this over to the side here. So we have Cu, copper, and it's telling us we have 2 of them, and we have CO3. Okay, so what's the charge on carbonate? Yeah, it's 2 minus. Okay, we know that because we memorized it, okay? Carbonate has a 2 minus charge. If we have, on this side of the ionic compound, we have 2 minuses. How many pluses do we need to have on our metal? Remember, copper's a transition metal, so it can form different variable charges, right? It can form a +1 or a +2. So how do we know which one we have? Well, if we have 2 coppers, we must have a +1 charge on that copper. Why is that? Well, if we have 2 coppers with each with a 1+ charge, that means we have 2 plus charges, which are going to cancel out with our 2 minus charges. Okay, if this was 2, and this is not correct, if each copper had a 2+ charge, because we have 2 of them, our total would be 4 pluses on the left. That's not going to cancel out with our 2 minus charge on our carbonate. So we must have copper as a 1+ ion, okay? So that those 2 can cancel out. So that's how we knew that we got that 1 there for our Roman numeral, okay? And the only reason we have that Roman numeral there, remember, is because copper is a transition metal, so it can form different types of charges. So we need to indicate that. Okay, if it wasn't a transition metal, you wouldn't need to put that there because it would always be forming the same ionic, or the same ion. Okay. Okay, and then that last one, 2 nonmetals, that's probably covalent, right? And then when it's covalent, we need to have those prefixes to show exactly how many atoms we have of each type. So we have N2O4, that means we have dinitrogen tetroxide, 4 oxygens.